My name is Scott Quire. I'm the Technical Director for Bluegrass Testing Laboratory. What I'd like to do is I'd like to take the next few moments to talk with you all about asphalt lab safety. As you know, during the course of this week, we're focusing on laboratory mix designs and all the things inherent with that process. When we start taking a look into a given asphalt laboratory and you look at the risk assessment or those potential areas of danger you may find through the lab environment, we're going to be talking about some of the typical recognized areas: a burn or chemical exposure to skin, to your eyes or your skin, inhalation of fumes or particulate matter, and then physical injuries from heavy material handling. So anyway, those are some of the areas, and we're going to elaborate just briefly here about each of these areas. When you start, first of all, talking about in the asphalt laboratory, the personal protective equipment we standardly see through most every laboratory, you should, is you're going to see long work gloves to protect your hands and your forearms, protective eyewear from flying objects, also exposure to the heat, for example, coming off an ignition oven, steel-toed shoes to protect your feet through all the heavy materials we're lifting in the laboratory environment, and then in your apron or lab coat, it's recommended because it not only keeps your street clothes clean, but also it's an extra layer of protection against thermal burns. So when we talk about asphalt burns in the laboratory, some of the potential sources for an asphalt burn, of course, is the asphalt muffle furnace or ignition oven, as we know it. It operates at 1,000 degrees Fahrenheit or 538 degrees Celsius. Also, another potential area for exposure to heat would be, of course, a hot plate or the heating tool and oven. We're heating materials to bring it up to the standard temperatures enough for asphalt mixing. So in turn, we have heated objects throughout the laboratory environment. One additional statement, of course, on asphalt burns is that, for example, if you're working with an asphalt ignition oven, and here in Virginia you would be, is that you have to be aware of the exposure to the heat. You can see this one picture on the left where, as you open the door, you have a flood of 538 degrees C air rushing out to meet you. So having heat gloves and then a visored protection gear for your face it's really quite a good idea, obviously. Also, even though the ignition oven has got shielding, thermal insulation, as you can see over here, picture on the right, that even when it's closed and in operation, they're around the outer edges. These ovens are exceptionally hot, so you have to be very careful because you can still get burned even with the door closed. And also, when you're operating an ignition oven, you never open the door of an ignition oven when it's in operation. Of course, we're standardly aware that like the Barnstead Thermalines and most of the ovens we use today, they have a locking mechanism that once the test is initiated, it prevents you from opening the door during the course of the test until it's concluded. So, but again, this is a potential source of burns in the laboratory testing environment. Asphalt burns, can't say enough about that, because as you think we're standardly working with asphalt binders that are heated up to standardly 300 degrees Fahrenheit or hotter, and so if you were to get any of that on your skin, it can cause severe burns. And so handling liquid asphalt must be done with care at all times, because again, it can hurt you very badly. And it's always critical that you wear personal protective equipment when handling liquid asphalt. So we've had experience to see people that unfortunately were burned in the laboratory before with exposure to asphalt. And so if that indeed does occur, it's critical that you go ahead and in your first aid testing or process is to place that burned or your coated, asphalt coated skin area under cool running water as quickly as you possibly can, and just keep flooding it with cold water. And of course, you don't try to remove the asphalt that's on your skin and now cooled and solidified, because by so doing, you're going to remove the skin with it as well. It's pretty tough, it's pretty gruesome, so you have to be exceptionally careful with this whole process. Of course, with no further statements, you have to seek immediate medical attention, because this is a very dangerous situation. Under chemical exposure, some of the sources for chemical exposure, of course, would be the chemical anesthetic agents we used in our TSR or moisture damage susceptibility testing, calcium chloride that we're using for our sand equivalent testing, and then, of course, the various solvents we're using for cleaning pans and apparatus, or even solvent extraction process in our testing process. Prior to use, of course, in fact, wise idea is to have, of course, eye wash stations located throughout your testing laboratory environment, and to know where those eye wash stations are in advance of any work that's concluded in the event that there is an unfortunate exposure. On inhalation of fumes, some of the sources, you look at the mixing operation, as most of us are familiar with, that with the heated materials, introduction of binders, there's the exposure of fumes. When you have additives added into the binders, there's usually a large potential source of additional exposure there. Your oven door, when you're opening and closing with asphalt materials inside, you'll see some smoke coming out with that. In the shaking and sifting operations during our gradation analysis, of course, there's exposure to particulate matter at that point. Asphalt burns, again, there's the smoke that comes off that. And when we're getting through with the testing process, and we manufacture gyratory specimens, I think each one of us, as we clean our gyratory molds, I know a lot of people will use like WD-40 or something like that. There's usually a large amount of vapors or cloud of vapors that will come off during that process. So to contain that in an acceptable manner in the laboratory, you need to be aware of that. That is a point of exposure. When we talk about heavy material handling, again, many of the things we're using in the laboratory, heavy buckets, gyratory molds filled with material, they tend to be typically heavy. A typical gyratory mold with mix in it's around 37 pounds. Can be, give or take a little bit, but anyway, nonetheless, if you were to drop that on a foot without steel toes, it could cause major injury. So in turn, we wear steel-toed boots in the laboratory, and then of course in all of our lifting process, to avoid back injuries, we want to be aware of that. We want to avoid awkward postures in our lifting process, because we can influence or induce injuries at that point. If there's any questions now, you can go ask your facilitator, and he will help elaborate.